Okay, this is the solutions to the semester exam review for Chapter 4. So let's get right into it. Problem number 1 involves your knowledge of various exponential properties. And so let's examine one of those. There's a couple of ways, 2 or 3 ways maybe, of going about simplifying this, but the way I'm going to do it is I'm going to go ahead and use my property that says two variables, same bases, that are being divided. You can subtract their exponents. You can make this become just a single x term using the difference between the exponents. Let me show you what I mean by that. So I'm going to say 3, I'll take care of the 3 in just a minute, but x to the third divided by x to the second gives me x to the first. Okay, 3 minus 2 is 1. And then the same thing for the y variable. It would be like this: y to the negative 2 minus negative 5 power. Okay, I'm dividing, so I subtract the exponents. But when you subtract a negative 5, of course, that means you're really adding. So that would be y to the third power. Okay, and all of this is going to be raised to the negative 2. All right, so let's take care of raising everything in the parentheses to the negative 2. So I'm going to do it a slow step at a time. There's 3 to the negative 2. X to the first raised to the negative 2. Remember, powers raised to other powers, you multiply those. That's another property of exponents. So that's x to the negative 2. And y to the third raised to the negative 2. Multiply those together, and you get y to the negative 6. Okay, well, we never want to leave an answer when we're simplifying. We never want to leave a negative exponent in our final answer. So the way we take care of these is 3 to the negative 2. Remember, negative exponents cause you to flip the base or write the reciprocal of the base. So the reciprocal of 3 is 1 over 3. And then you can change the exponent to positive. So 3 to the negative 2 is really 1 over 9. Okay? X to the negative 2, same thing. X to the negative 2 is really the reciprocal of x to the positive 2. All right? So no need really to write another times 1 here. I'm just going to write, you can pretend that's 1 over x squared. It would be like multiplying 1 times 1, which is still 1. All right? And then in a similar way, we have y to the negative 6. Negative exponents force you to write the reciprocal of the base. That's the number underneath the exponent. And then you can change the exponent to positive. So once again, I'll just show it like this. And obviously, I don't need 1 times 1 times 1 is just 1. So we'll show it as a single 1 in the numerator, and all of these being multiplied together. Don't really need the multiply signs because it's implied that all these are multiplied together if there is no sign. So that is your final answer for number 1. And again, you could have done that differently and you would have gotten the same answer. But that's the way I think about it. I like to consolidate these like variables that have exponents first. Cleans it up a little bit. Okay, let's try this one. Another same properties being used. Everything in this left group, this left monomial, needs to be raised to the second power. So negative 5 to the second power times x squared raised to the second power. Let's go ahead and use our property. 1 power raised to another means you multiply those exponents together. 2 times 2 is 4. And when you raise 4, y to the fourth, to the second, multiply again, you get y to the eighth. All right, that takes care of raising everything in this left monomial to the second. And nothing really needs to be done before we multiply with this right monomial. So now we're ready to multiply these together. So you multiply coefficients. Now this is negative 5 squared. Okay, so negative 5 times negative 5, that's 25. and 25 times 2 is 50. Now when you're multiplying and the bases are the same, like we have here, x to the fourth times x to the third. Remember that property. Multiplication of like bases means you add the exponents together. So that's going to be x to the seventh power. And the same property here with the y. This is going to be y to the 8 plus 2 power, which is y to the 10th. And that is your answer for number 2. Okay, number 3 says use your method of choice, and that refers to either Pascal's triangle or the binomial theorem. And I think I'll just go ahead and show both because I don't really know which one you like the best. So make sure both of them are covered. So for the triangle, you need to understand first of all how to make the triangle and how far to go. You don't need to make it too far for this one. We just need to be able to cover the exponent 4 expanding to the fourth power. Well, this would be exponent 0, this would be exponent 1 row, this would be exponent 2, exponent 3 has the 4 number, so I just need to go one more row if I'm going to use Pascal's triangle. So that's the row that will be used. These are coefficients that are used in the expansion. So let's just walk through how to expand this, and we should end up with 5 terms when we're finished. Alright, so we start with 1 times, now look inside, and we're going to raise this first term of the binomial x to the fourth, and we raise the second term, 3, it starts off at the 0. Okay, and then we get the next number, and the pattern continues. X now drops down by 1, 3 will go up by 1. Next number from the triangle, x goes down, 3 goes up. Next number from the triangle, x goes down, 3 goes up. And then the final number from that row, x is down to the 0, 3 is up to the fourth. And this is just used to help us get to a simplified, you never want to stop with this, but it's useful to help you come up with your final expanded answer. So this is 1 times 1, 3 to the 0 is 1, so that's just going to be x to the fourth. Alright, we have a couple of constants here that can be multiplied together. 4 times 3 is 12, x to the third. Same deal here, this is going to be 6 times 9. 6 times 9 is 54, x squared. Okay, 3 cubed is 27. 27 times 4 is 108. X, and then we're down to 1 times 1 times 3 to the fourth, and 3 to the fourth is 81. Alright, so that is the answer. Whether you use the triangle or the binomial theorem, you should have gotten that same answer in either case. But if you did use the theorem, the only difference really is how we come up with these coefficients. Alright, so let me just highlight these coefficients. Everything else works the same. These numbers that we got from the triangle, if you use the binomial theorem, instead of just looking at the triangle and getting 1, you would think of calculating in your calculator. Since it's raised to the fourth power, you would do 4 NCR 0, and that would have given you 1. Everything else works the same. To get 4, instead of looking at the triangle, you would do 4 NCR 1. Alright, and then to get 6, you would do 4 NCR 2. Everything else is the same. To get 4, back to 4 NCR 3. And then finally, to get this 1, you would have done 4 NCR 4. So notice how we start at 0 always. Still going to get your 5 coefficients just like you did from the triangle, but it's just a different way, a different method of getting these coefficients. It's using these combination factors in your calculator. But that's the only difference. Everything else you should have used the same line of thinking, same practice. Alright, so that is your answer for number 3. Number 4. Now we are the easiest way to take care of these, I think, is to use the binomial theorem, because out of the total of 9 terms that would be involved in this expansion, we only want to know what the third one is. And using the theorem, okay, remember this would have started at 8 NCR 0 for the first term. 8 NCR 1 would be the second term, 2 would be the third, 8 NCR 3 would be the fourth, and so forth and so on. So if we just want to know what the third term is, then you can remember it this way. This number to the right of C, the combination, will be 1 less. So you're going to do 8 NCR 2 times, look inside the parentheses, and you can raise this variable, this whatever it is, to the difference between these. This is kind of a shortcut way of coming up with this answer. Again, if you wrote it out long ways, you start off with r to the 8th, and then your next term would be -3 to the 0. Remember, just like we did on the previous problem. So for this, that's the first term. For the second term, this would become 1, this would become 7, this would become 1. For the third term, this would become 2. All right, you already see that. This drops down another to 6, and this goes up to 2. Okay, and then the pattern keeps on. So we just pretty much already answered how to get the -3. It's going to be raised to the second power. And another way to remember this is the number to the right of C should always match this exponent for the second term. They should always agree. Okay, so some things you can check before you just jump right in. These two exponents should always add up to this left number. This right number should always match the second exponent. Or another thing you can check is the difference between these should be the first exponent. So there's a lot of things you can do to double check. And now you just grab your calculator, and I'll erase this since we're just kind of using that to reason through this. But in your calculator, if you do 8 NCR2, you should get 28. Of course, r to the 6. And then this -3 squared is 9. Okay, and basically all we have to do is multiply 28 times 9, and we get 252 and r to the 6th, and that is our third term in this expansion. All right, number 5, also utilizing the binomial theorem for probability answers. So we read this problem and we notice that Henry is a 75% free throw shooter, or another way of saying that, he is successful 75% of the time. So start by just writing down that likelihood, in this case, of success. And you'll always write down the percentage that's given in the problem. Okay, and that's given 75%. And beside that, think about the alternative. If he makes 75%, then he misses 25%. So this is a good way to set these problems up. Take the probability that is provided, write it down, and then immediately beside that calculate the alternative to that, or what's the other probability that would make 100%. Okay, these two together, 75% plus 25%, total makes 100%. Because the bottom line of these is there are only two possible outcomes: the one you're given, and then the difference, minus 100%. Or if you leave it in decimal form, it would be that minus the decimal. 1 minus the decimal would give you 0.25. Percent form, it would be this. But we always change them to decimals, so if you want to get this alternative likelihood in decimal form, you can just take 1 and subtract the decimal that you're given. And that will give you the other decimal. Okay, so we're going to raise these to certain powers depending on what the problem is asking for. Find the probability that he will make exactly 5. So that's easy enough. We take the make probability, raise it to the 5th power. He's shooting a total of 9 in this particular example. So just think about this. If he shoots 9 and he makes 5, then he must have missed 4. Okay, so I raised the make likelihood to the 5th because that's what the problem is asking me to determine. And then I just put the miss exponent as the difference between that and 9. And then finally, once again, this is one of the terms of a binomial expansion, so we need a combination factor. Take the total, in this case, the total number of free throws, the total number of attempts, and then remember, just like we looked at here, this number to the right of C should always match the number, the exponent for what we're calling this second probability, which is always, if you set it up this way, it will always match the either failure or the alternative to what was given in the problem. So this second exponent and this second number, the number to the right of C, should always match each other. And now grab your calculator, and you can pretty much do all of this as just one line. You're going to do 9 NCR 4 times 0.75, and you can raise that using that little character, that upside down V shape, to the 5th times 0.25. Use that button again on your calculator, raise to the 4th, and then hit equals. Okay, and on your calculator it shows a decimal of something like this, 0.116794. That's the decimal form, but our answer is supposed to be in percent form, rounded to the nearest hundredth. So you can think of this in two ways. You can either just move the decimal 2 places to the right, or if you just want to leave that number in your calculator and multiply it by 100, that will give you the decimal form. So it should be 11 point, and it's 0.679, and since we're supposed to round to the nearest hundredth, that would be 11.68%. Okay, hundredth is the second decimal place. And that's your answer for number 5. All right, let's do a long division problem. So we'll set this up in the old traditional long division form. And when you do long division, you're really dividing the first term of this binomial into the first term of this polynomial, this cubic polynomial. So a divides into a cubed, a squared. So I'm just going to match these up. And now I'm going to multiply a squared times both of these. All right, just think distributive property. A squared times a, it's a cubed. A squared times -3, -3a squared. And with long division, you always subtract here. So the a cubes cancel. -6 minus -3 is really -6 plus 3, and it's -3a squared. Bring down the next term and repeat. First term, a into first term. -3a squared. That goes -3a times. Now multiply. -3a times a is -3a squared. -3a times -3 is positive 9a. Once again, we're going to subtract. The a squares cancel. 10 minus 9 is 1a. Bring down the next term, the last term. And a into a goes one time. And we multiply by by 1. And in this particular case, we do not have a remainder. So my answer is a squared minus 3a plus 1. All right, moving on to numbers 7 through 10. These are seeing if you can understand based on the graph the end behavior. That means what's happening going to the right forever and to the left forever. Picking up on things like how many real number solutions are there, how many x-intercepts are there. That will help us with the degree. And another thing we mentioned when we were covering this is how you can tell whether the lead coefficient of a function is positive or negative. Let me just take number 7. We'll just start walking through these one at a time. I noticed that this function, the right end, is up forever. It's going positive, positive infinity along the y-axis, and it will obviously continue to do that. So what this tells me is that the lead coefficient of this function has to be positive. What I mean by the lead coefficient is the very first number in the function. For example, the lead coefficient for this letter A function is -4. Lead coefficient here is +1. All right, so I've ruled out letter A. There's a couple of reasons to rule it out, but number one, the lead coefficient here is negative, so this can't be letter A because the lead coefficient here has to be positive. All right, another thing that I'm noticing is this has to be cubic or third degree because it's crossing the x-axis at 3 real number places. There are 3 zeros. All right, so I've ruled out letter A already, and there's only one other cubic. It does have a positive lead coefficient, so I'm matching up letter C with this function. All right, so we've taken care of that. Let's take a look at this. This has to be quadratic. It's got 2 x-intercepts, 2 real number solutions, so we're looking for something squared, and that's easy enough because there's only one function given that's quadratic, and that's letter B. All right, now we're down to these final 2. This has to be an even function because the right side and the left side are matching, so it's got to be a degree that's an even number, and that's easy enough to determine. There's only one left that's even degree, 4th degree, and that's letter D. Another thing to be on the lookout for, notice that the right side goes up forever, so the lead coefficient has to be positive, and so that's true. So that's got to be D. And then by process of elimination, of course, we see that this has to be A. Couple of things to look for. You might be thinking, well, it doesn't cross the x-axis 3 times, but there are 2 turning points. We've talked about that. There's a turning point here, and there's a turning point here. So the thing that's true about the degree is your graph will illustrate exactly one fewer in the number of turning points from the degree of the function. So a 3rd degree function should have 2 turning points. A 6th degree function should have 5 turning points. All right, so the number of turning points will always be exactly 1 less than the degree. Something else, remember this lead coefficient being negative, so that should represent a function that goes down forever on the right. All right, so lead coefficient here must be negative. So I know that's pretty obvious, the letter is A, but I'm just trying to help you for future reference how you can look for clues on how the graph matches up with a particular function. Okay. It's one more thing, since it's odd, of course, the right and the left side should be doing opposite things. They should be going in opposite directions. Okay, so I think we've covered all the important information about degree in behavior that pertain to the graphs of these polynomial functions. So be on the lookout for those types of questions on your exam. All right, number 11 says if we have this function called d, how do we come up with this? It says 5 times d, and then once we do that, we're going to input 2a. So let's do 5 times d first, and literally that means multiply 5 times the d function. So we'll use the distributive property, negative 5x cubed plus 5x plus 5. And now that we've done that, we've done the 5d part, this means to input 2a in place of x. So that's going to be 2a cubed, 5 times 2a, plus 5. Powers before multiplication. So we're going to be multiplying negative 5 times 8a cubed. All right, and that's going to be negative 40a cubed. This is going to be 10a plus 5, and that's our final answer for this. So function operations is what this is called. Make sure you can multiply first, and then this doesn't mean multiply again by 2a. This is referring to the input into the function after doing this function operation. All right, 12 and 13, we want to make sure that you're able to factor, and these are two new different ways of factoring that we covered that you probably didn't see in Algebra 1. This represents the difference between two perfect cubes. Now, I just want to alert you, you also need to be prepared for the sum of two cubes. All right, even though I didn't put it on this, it doesn't mean that you won't see it on the exam. So just be ready for both the sum and the difference. And they're very similar, but there's a slight difference in how the factoring is done. All right, so the way we factor the difference between two cubes is we first come up with the cube roots of both of these terms. The cube root of 27x cubed is 3x minus, and then the cube root of 8y cubed is 2y. And then from there, I'm going to make a trinomial that is built off of these terms. All right, so the first term of the trinomial will be this first term, 3x squared. Okay, I will follow that with a plus always. Now I'm going to multiply these together. 3x times 2y is 6xy plus, and then I'm going to square the second of these terms in the binomial, and that's 4y squared. And that is the factoring of this number 12, factoring as the difference between two cubes. All right, so now let's jump over here and factor this, and this is known as factoring by grouping. So you need to be looking for common terms, either they could be common within 3 groups of 2 or 2 groups of 3. And what I'm noticing here is in this first group of 3, there's a common y cubed term. And with this next group of 3, there's a common z cubed. Okay, they don't always set up so well as this one does, where first 3 are common, next 3 are common. Sometimes you got to look and separate or put them together in terms of their commonality, but this one pretty much already sets up for us. So let's factor out that y cubed in this first group of 3, and that gives us x squared minus 3x plus 2. All right, and then I'm just going to bring down this next sign, and we'll factor out the z cubed from this next group of 3, x squared minus 3x plus 2. And it's great when we see that these the parts that are these two trinomials, whatever's in the parentheses, when they match, we know we've done the right thing. So we'll put the terms that are not in parentheses together, make a group, and then this matching, this is like a GCF, will be my other group. Now we can still factor. Okay, so as I mentioned earlier, we've already done the difference between two cubes. Well, this represents the sum of two cubes. So here's how we factor the sum of two cubes. The cube roots. All right, and now we square y minus, multiply these together, plus, and then square z. All right, we can also factor this quadratic trinomial because there are factors of 2 that add up to -3. So two linear binomials, both of them minus because it's minus in front of plus, and we would do x minus 2 times x minus 1. So a lot of factoring that can be done in this example. And that is your answer for number 13. All right, now let's solve some polynomial equations. Generally speaking, anytime you have a quartic trinomial, it's going to be factorable using two quadratic binomials. So it's very similar to what we were doing factoring quadratic trinomials. We're looking for the factors of -24 in this case that would add up to +5. Now both of these have to be x squared. So the factors of -4 that add up to +5 will be +8 and -3. So just do a quick little FOIL check and make sure that you can multiply these together. That's what factoring is. Rewriting a given expression using multiplication of two or more factors. And I noticed that when I multiply these together with FOIL that it does match. All right, so don't go any further if you've done a quick little mental FOIL check and these multiplied together do not agree. Okay, and now that the factoring has been completed, just think of each factor being its own separate equation equal to 0 and solve each factor. So here I've got x is plus minus the square root of -8. Now that can be simplified. And the square root of -8 would be 2i square root of 2. Don't forget plus minus. Remember, I'm looking for 4 solutions. All right, so there's 2 solutions. And now let's solve this as x squared equals 3. X equals plus minus the square root of 3. So there are my other 2 solutions for a total of 4. And that's your answer for number 14. Number 15, here we have the sum of two cubes again. So you need to be really good at factoring these. The cube roots first, and now make a trinomial based on these. Square the first of the terms, x squared, minus, be careful here, multiply these together, that's 3x, plus, and then square the last. Okay, and then this is the factoring. So just like we did before, just take each factor, set it to 0, and solve. All right, this one is pretty simple. That is one of our 3 solutions, -3. This one, we're going to get our other 2 solutions out of this, but we'll have to either use the quadratic formula or completing the square. It doesn't factor. So I'll do what most people would do, probably use the quadratic formula. Opposite of b, plus minus b squared minus 4 times 1 times 9, all over 2. That's the square root of -27. And the square root of -27 simplifies as 3i square root of 3. And if I could reduce by dividing these all by the same number, besides 1 of course, I would do that, but there is no number that would divide into all of these. So that ends up being my simplified answer. So 3 solutions, -3, and then these represent 2 different ones because of plus, minus. All right, moving right along. Number 16 says use synthetic substitution to find f of 6. Well, we used to do f of 6 like this, just to make a connection to the old days. and you probably want to grab your calculator and get that answer. So that's what f of 6 means. But when we use synthetic substitution, it means this. We're going to use synthetic division basically. And so I use the coefficients 2. Notice I've skipped over the x cubed term, so I'm going to plug in a 0, -5, 8, -7. All right. And so synthetic division works like this. Bring down the first number. 2 times 6 is 12. You always add with synthetic division. 12 times 6 is 72, and then this is 67. 67 times 6 is 402. That makes 410. And now we're going to do 410 times 6. And that's 2460. And then 2460 basically minus 7 gets us to 2453. All right, and so our answer is the remainder. This is an example of the remainder theorem. And if you had done the same thing like this in your calculator, you should have also come up with 2,453. Okay, so that is your answer for number 16. Number 17, we're also going to use synthetic division. If we know that one of the factors is x minus 2, there should be a total of 3 factors. Since it's cubic, how do we find the other 2? Well, we're going to use synthetic division. Remember, synthetic division says if we're given a binomial to divide by, then the number we put in the house is really just this number. So you got to be careful. It looks like you should use -2, but you're only using this number. Okay, if we were dividing by x plus 2, then the number that we would put in the house would be -2. So this is another one of those cases where you really have to be careful, and with synthetic division you're given a binomial. Notice we weren't given a binomial here. We were given the number to actually use. But if you're looking at a binomial that you're dividing by, you really have to think the opposite of the way it looks. That's a common mistake that people make. All right, so I got 2 in the house, and my coefficients are 1, -7, 4, and 12. And paying attention to see if I skipped over any exponents, and we didn't. All right, so synthetic division, bring down the 1. Always add. Multiply, -5 times 2, add, -12, and that should happen if I'm told that this is a factor. That means it should always give me a remainder 0. So that's not the most important reason for doing synthetic division. It's because of this. The way I'm going to get the other 2 factors is by writing this as a quadratic. Notice I divided into cubic, so the result should be quadratic. And when I factor this, I will have the other 2 factors. All right, so this is really the big takeaway from doing synthetic division. And so the factoring of this is x minus 6 times x plus 1, and that ends up being my final answer. These are the other 2 factors of this cubic polynomial to go along with x minus 2. All right, so we are moving right along. Let's take a look at numbers 18 and 19. Finding the zeros of this function. There should be 3 here, 4 here, and this one, whenever you are dealing with these polynomials that will not factor, you're going to have to use what we call the rational root theorem and synthetic division. Now remember, I told you of a little pattern that sometimes shows up that makes finding the first 0 very easy, and it happens to show up in number 18. Because if I take the coefficients 1, 7, and 4 and I multiply them together, it happens to equal the constant. And so my 0 that I'm looking for, without having to go through a bunch of testing of all the factors of 28, I know that that 0 that makes remainder 0 is going to be the opposite of whatever's in front of x squared, which is -7. So that's just a little trick that we talked about weeks ago that will save you a little bit of time. And whatever you can do on the exam to save yourself time is to your benefit, obviously. So we still need to do the synthetic division part, but we know what number works to start with. So here I am, 1 times -7, -7 plus 7 is 0. That makes 0 when I multiply. 0 plus 4 is 4. And then when I multiply here, I get -28 plus 28 is 0. Alright, so I'm looking for 3 zeros. -7 is one of them. Now I'm going to find the other 2 by letting this represent a quadratic equation. So just keep in mind, once again, if I divide it into cubic, the resulting polynomial should be quadratic, just 1 degree less. So let's solve this. X squared is equal to -4. X is equal to plus minus 2i. So our 3 zeros, one of them is real, 2 of them are imaginary. So if we're thinking about the graph, this would only cross the x-axis 1 time. It would have 2 turning points, but it would only show actual x-intercepts at -7, just one x-intercept. Okay, so that's your answer for number 18. So in a similar way, let's do number 19. This one doesn't have that particular pattern I taught you, so we're going to have to test the factors of -10. And there's not too many. Our first, if there is a real 0, it'll come out of this group. All right, the factors of -10. So you can start testing. We'll set up the synthetic division process. So 1, 1, 1, -9, -10. And it doesn't really matter where you start. I'm just going to start with this factor 1. So let's see what we get. Bring down the 1, multiply, add. 1 plus 1 is 2. 2 plus 1 is 3. 3 multiplied plus -9 is -6. -6 plus -10 is -16. So I didn't get a 0 remainder, so 1 is not a 0. Well, let's try -1. All right, bring down the 1. -1 plus 1 is 0. 0 plus 1 is 1. Multiply -1 plus -9 is -10. +10 when I multiply plus -10 is 0. So one of my 4 zeros is -1. So this resulting set of numbers represents a cubic polynomial. There is no x squared term. So once again, let's see if we can figure out the other 3 zeros using the rational root theorem. 1, 0, 1, -10. All right, so we're still pulling from that same set of numbers, and so we can just test 1 again. 1 times 1 is 1, plus 0 is 1. 1 plus 1 is 2. 2 plus -10 is -8. Right? So we can try -1. -1 plus 0 is -1. 1 plus 1 is 2. -2 plus -10 is -12. Okay, so it looks like I'm getting further away when I choose negative. So I'm going to go back to positives. I'm getting more negative when I chose a negative test. So let's try 2. 1 times 2 is 2. Plus 0 is 2. 2 times 2 is 4. Plus 1 is 5. 10 plus -10 is 0. So we found another 0. And so now we're down to, this was cubic, so this should represent a quadratic. X squared plus 2x plus 5 is equal to 0. So now we don't need to go through this table any longer. We know how to solve quadratics. It doesn't factor, so I'm going to rely on the quadratic formula. So let me just get a little space here. So the opposite of b plus minus the square root of b squared minus 4 times 1 times 5, that's 20, all over 2 times 1. So simplifying, we have the square root of negative 16. Let's see if we can just go ahead and do some little mental math here. The square root of negative 16 is 4i all over 2. And now simplify. Just divide by 2, and you get negative 1 plus minus 2i. Okay, so our 4 zeros, we have 2 real number zeros, negative 1 and positive 2, so we'll cross the x-axis twice. Even though it's quartic, we will have 2 x-intercepts, but then we will not cross the x-axis according to this, because these are complex number solutions. So here's my final answer: negative 1, positive 2, negative 1 plus minus 2i. And I think that's it. So that concludes the review material for Chapter 4. So work hard on these and let me know if I can help.